Hello there, Mr. Sutton here with the AB Calculus 3.5 lesson on the product and quotient rules. In this one, we will find derivatives of products by simplifying first and using something called the product rule, and we'll do the same thing for quotients, both by reducing and by using the quotient rule. For the warm-up on this one, see if you can figure out the derivative of this function based off of what you already know for sure. All right, the only thing we really know for sure is the power rule. So if you're not sure whether or not you can use the power rule on this first and then multiply it out versus multiplying it out and then using the power rule, let's do the safe side and multiply everything out first. So this is going to be 8 times 300, that's 2400. And then we have 8 times negative 20x, that's negative 160. But we also have a 300x if we multiply these inners out. So that's a total of 140x. And then we've got x times negative 20x, that's going to be negative 20x squared. Using the power rule from left to right, we've got the 2400 zeroing out. This is going to be 140 minus, this is going to be, let's see, 40x. And let's just see if we would have gotten the same thing by taking the power rule first and then multiplying. So this part here would have been 1. This would have been negative 20. If you multiply 1 and negative 20 together, you do not get this. So yeah, you need to distribute first and then use the power rule. So we just saw that we can simplify something like this and then use the power rule as one way to take the derivative. There is another way. And the reason I'm going to show you this other way is because it's a little more universal. It does not rely on being able to simplify a product. I mean, if you have two polynomials, then go ahead and simplify. But what if this was a trig function times, say, an exponential function, right? Nothing happening there. So the more universal way, which is called the product rule, is as follows. And we'll do it again on this problem we just did, just to show you do get the same answer. So the product rule says that the derivative of the product of two functions, so derivative of uv, and we'll call u and v our two functions here, is going to be the derivative of the first function, so u prime, times the original second function, so v, plus the original first function, u, times the derivative of the second function, v prime. So basically, you take the derivative of one function at a time, multiply these things together, and add them. That's the basic operation here. Now, at the risk of showing you too many new things at once, I'm going to show you kind of a way of organizing this that I like to call the box and ribbon method. And you don't have to use this, but this is one way to organize it, especially if you have some nastier functions to kind of keep track of so that you don't get lost and you actually end up including everything. So I'm going to set up a little box here, and in the upper left and the upper right, I'm going to put my original functions, u and v, and down in the lower left and lower right, I'm going to put their derivatives, u prime and v prime. So I keep things nice and organized. So my original u function, and it doesn't matter which one you use, but I always like to use the first one, but really it's multiplication, so either one is fine. So we've got 8 plus x, and then v, that's going to be 300 minus 20x. So go ahead, pause the video real quick, and figure out u prime and v prime. All right, so for u prime, we have the derivative of 8 plus x, which is just going to be 1. And for v prime, we have the derivative of 300 minus 20x, which is just the constant negative 20. So at this point, I'm going to use kind of a ribbon sort of shape to tell me what order to multiply these things in. So we're going to have u prime times v. So I have starting here, I have a kind of a little ribbon going this way. And then I'm going to have u v prime. So before I go the other way on the ribbon, let me actually keep track of what I've multiplied. So I've got 1, that's u prime, times 300 minus 20x, that's v. And now going back the other way, we've got u, that's 8 plus x, times v prime, that's negative 20. Now, normally, if this was just the final answer, you wouldn't have to simplify it. However, I'm going to simplify it just to show you that we do get the answer we got the other method. So 1 distributed to all of this stuff is just 300 minus 20x. And then we have 8 times negative 20 is negative 160. And then x times negative 20, that's negative 20x. Combining like terms, we have 300 minus 160, that's going to be 140. And then those negative 20s are going to give us a negative 40x. So 140 minus 40x, which is exactly the same as what we got the last time. We'll do one more example. So we've got the graphs of some piecewise linear functions, f and g given above. And then we have this random h function defined as f of x times g of x. We want to know h prime of 2. Pause the video and see if you can use everything we've done today to figure this out. All right, so here we see that we've basically got a product, and this is not like those problems with polynomials where you can just distribute it out and use the power rule. Here it's product rule or nothing else is going to work. So let's write out our product rule, u prime v plus uv prime, and it's plus now because we're using product rule. Let me set up the box and ribbon to organize all of this. So I've got f of x, g of x, and then their derivatives, which are f prime and g prime. Now we wanted to actually plug in x equals 2, so let's plug that in inside the box and ribbon. So this is going to be f of 2, which I need to read off of the graph of f. So at an x value 2, we have a y value of 4. And now g of 2, that's going to be on the g graph here. At an x value of 2, g of 2 is going to be 5. Now we need f prime of 2. That's going to be the slope of the f graph at x equals 2. So we come back here, and this looks like we have a slope of 2. We're going up 2 over 1. Pretty easy to read because it's on a straight line. And then finally, g prime of 2, that's the slope over here, which is just 1. Putting it all together now, we've got 2 times 5 plus 4 times 1. And this is another one of those situations where if it was free response, you could just leave it like this. But because it's multiple choice now, you do need to simplify this. So 10 plus 4 is 14, giving us choice C. So we'll revisit the product rule later on. For now, we're going to talk about quotients. Pause the video and see if you can do this problem based off of what you already know. All right, so you could actually use the product rule on this one. Doesn't necessarily mean you should, but you could move this x upstairs as an x to the negative 1, and then you know how to take the derivative of that and the stuff that's already up there. Now, it would be a little bit faster if you actually just divided everything by x to start it off, though. So we've got 5x squared plus 6x, and then just using our power rule, we've got 10x plus 6. Let's take a look at this next problem now. So taking a look at this one, it looks like we can't reduce this like we could example 3 to just a polynomial. If you can't reduce something to a polynomial, you're going to have to use something called the quotient rule instead. So here's the quotient rule. Now this is actually a lot like the product rule. We have a u prime v and a uv prime, but instead of adding them, we're going to subtract them like so. And the u and v, that's the numerator and denominator respectively. And now, instead of just keeping it the way it is, we're also going to divide by v squared. And this is going to take the derivative of a quotient. So let's go ahead now and set this up. Now, the good news is we can use the box and ribbon again because it's pretty much the same pattern and the same things we're finding. We're just going to make our ribbon look a little different after we do it. Pause the video and set up the box based off of how you did the product rule before. All right, so in the upper left here, we've got u, which is our numerator, 2x minus 1. Our denominator v, 3x plus 2, that's going in the upper right here. And down below we have u prime, which is 2, and v prime, which is 3. Now we're going to do a little bit of a different process for the ribbon because we have this v squared to worry about. So I'm still going to start in the lower left. We're going to have 2 times 3x plus 2, so that's not really any different. So following the ribbon here. And then we're going to have upper left times lower right, so 2x minus 1 times 3. But you have to be careful because with the quotient rule we are subtracting instead of adding. So this will be minus 2x minus 1 times 3. And I'm going to have to be extra careful to use this parentheses here now. And then finally down below we're going to kind of tie off the ribbon here and do this upper right squared. So 3x plus 2 quantity squared. Now if I wanted to, I could go ahead and simplify this, but it is a free response, so this is algebraically equivalent to whatever answer I needed to get. For this next example, we're going to check multiple boxes at once here. For one thing, you might have been wondering, well, when would I need to simplify? So on this problem, we're given this table of values of f and g and their derivatives, and we need to show that the derivative of f of x over g of x, evaluated at 3, that's what this notation here means, has a value of 7/8. So here you actually need to figure out what this thing reduces to in order to prove that it is this number. We also need to actually plug a number in. So let's start this by pausing the video and seeing how far you can get just based off the fact that this is a quotient and you now know the quotient rule. All right, so here's our quotient rule again. I usually like to write this out before I do anything else. I don't get anything for writing this out in terms of points, but it helps me organize things. And then my box and ribbon over here, I've got f of x and g of x. Those are my actual functions. And now their derivatives are going to be, this is very simple, f prime of x and g prime of x. Now, if you want to evaluate things, I could actually write this all out. So f prime of x times g of x and all the rest of it and plug it in here. But you can actually plug in numbers inside the box. So let me show you that. If x equals 3, which it does here, let's see what happens to all these things if I plug in 3. So f of x with 3 plugged in, that's the f of 3. In our table, that's 6. Now, g of 3, in our table, that's negative 4. F prime of 3, we're told that's 10. And then g prime of 3, that's going to be negative 9. Now I'm going to use the ribbon and actually plug everything in. So I've got 10 times negative 4 minus 6 times negative 9. It's minus because this is quotient rule. All of that divided by negative 4 squared. Now at this point, although I could leave this the way it is if it were free response and normal free response, they said show that this derivative is 7/8. So I actually have to simplify this a bit and show that this equals 7/8. So up top we've got negative 40 plus 54, which is 14. Down below this is going to be 16. And then 14 over 16 clearly reduces to 7 over 8. So we've done what they asked. So that'll be it for this one. Hopefully you found our time productive. Until next time, Mr. Sutton signing off.